It didn't happen with fireworks or a big announcement. It happened quietly, almost in silence. You see, for decades, some of the brightest minds have been wrestling with these incredibly complex scientific problems. Problems so difficult they seemed almost impossible for humans to solve alone.
And then recently, well, the silence was broken. But not with a shout. It was more like the quiet click of a puzzle piece finally sliding into place.
Exactly. An AI, working with a scientist, solved a physics mystery that had stumped everyone for generations. It's kind of a big deal. And this deep dive isn't about some flashy new tech trend, the kind that grabs the headlines and fades just as fast.
It's about a much deeper shift.
Yeah, a much deeper shift. One that was captured in a paper published on April 1st, 2025. This paper, it signals a huge change in how we understand intelligence itself. What if this is how AGI, artificial general intelligence, really begins? What if it's not these dramatic pronouncements and flashy demos that mark the beginning? What if it's just this quiet, steady solving of problems that we thought were unsolvable?
It's a really compelling thought. This changes everything. And what's fascinating is that hardly anyone seems to be talking about it.
Oh, no. But Dr. Alan D. Thompson, he's a leading researcher in AGI. He's definitely noticed. He sees this collaboration between the AI and the scientist as a major sign, a key signal of what might be coming.
Yeah, the quietness of this breakthrough really is striking. I mean, we're bombarded with all this hype about AI. Every day there's a new story, a new claim. But this was different. This was a profound problem solved with, well, almost an understated efficiency. I think it really makes us question the very nature of discovery, how these breakthroughs happen.
Okay, so let's get into the details here. At the heart of this breakthrough is something called the Potts model.
Right.
And when we say model, we're not talking about, fashion models or those tiny model airplanes people build.
No.
This is a mathematical model, a kind of conceptual framework that scientists use in a ton of different fields, from material science to quantum physics to superconductivity. These are some of the most fundamental areas of science, stuff that helps us understand how the universe works at the deepest level.
Exactly. And the specific problem they cracked was the one-dimensional J1, J2 Potts model.
Okay, so one-dimensional J1, J2 Potts model.
Right. And what made this so difficult to solve for so long was finding a mathematical expression that worked for all possible values of Q.
Q?
Yeah.
Yeah.
It represents the number of states or spins that the elements in the model can have.
So imagine a line of like a billion tiny magnets, all in a single row. And each magnet, instead of just pointing north or south, it has a dial with, let's say, 5 different settings.
Okay.
And each magnet interacts with its neighbors on either side. So the question becomes, what are all the possible stable arrangements these magnets can settle into? And how do you come up with a mathematical rule and equation that accurately predicts all of those configurations no matter how many settings the dial has?
You can see why it's a huge challenge. It gets really complex really fast.
Really complex. And it's not just some abstract math puzzle either. Understanding how these theoretical particles arrange themselves, it gives us crucial insights into how real materials behave in the real world. And that could lead to all sorts of new technologies, materials with properties we can't even imagine right now. It's about understanding the fundamental language of how matter organizes itself, how things come together.
Exactly.
And that's where things get even more interesting. Enter OpenAI's GPT-4o, or, as they call it in the research paper, O3 Mini High. Now, it's super important to understand that the AI didn't just magically pull the answer out of thin air. This was a genuine collaboration between the AI and a human scientist.
Absolutely. The scientist was essential. They framed the problem, asked the right questions, guided the AI's exploration. But the AI, it brought something truly remarkable to the table, a new kind of insight. It showed a deep understanding of how the Potts model worked, its underlying structure. And that's already pretty amazing.
Yeah, but then it did something even more incredible. The AI found hidden symmetries within the problem, these subtle patterns and relationships that humans had missed for decades. Imagine these brilliant scientists poring over this problem for years, and the AI comes in and spots something completely new.
And these symmetries, they weren't just interesting. They were the key to simplifying the whole thing. The AI managed to take this massive, complicated 9x9 matrix, which basically represents all the complex interactions within the model, and it reduced it down to a much smaller, much more manageable 2x2 block.
So it's like the AI found a secret passage, a shortcut, through this incredibly dense mathematical jungle.
Exactly. And by simplifying the problem like this, it made it possible to find an exact solution, one that works for all the values of Q that had been so elusive before.
So this wasn't just the AI crunching numbers and spitting out an answer. It was actually reasoning, making logical steps, guided by the scientists, but not totally controlled by them. It starts to feel like we're seeing something beyond just pattern recognition. It's like the AI is actually thinking.
It really does.
Yeah.
And it raises this huge question. What does it mean when an AI can not only understand a complex model like this, but also find these hidden symmetries within it? It suggests a capacity for abstract thought, an ability to see fundamental relationships that we usually associate with, well, with human intelligence.
And that's why this seemingly quiet event, this paper published without a lot of fanfare, it's actually a landmark moment. And the sources we've looked at, they're very clear about this. This is the first time an AI has played a crucial role in finding an exact solution to a long-standing unsolved problem in theoretical physics. It's not just an incremental improvement, it's a genuine breakthrough.
And I think the quietness of it all makes it even more significant. It wasn't a big media event, no press releases or flashy presentations. It just happened. And sometimes the most profound changes, the ones that really shift the course of history, they start that way, almost unnoticed.
It really is like a tipping point, a moment where we see an AI doing something that looks a lot like, well, thinking like a scientist. And for our listeners who are always eager to learn and stay ahead of the curve, this is a crucial insight into what might be one of the biggest developments of our time. It's happening right now, right under our noses.
And it connects to the larger trends in AI research, too. Dr. Alan D. Thompson, he's a leading figure in the AGI field. He actually included this paper as checklist item #5 on his ASI readiness list. He sees it as a definitive signal of general intelligence. And coming from someone like him, that's a huge statement. Now, unfortunately, we can't experience the live stream right now, but just knowing he included it speaks volumes.
Absolutely. And the implications go way beyond theoretical physics. This paper raises some really big questions that we need to be asking ourselves right now. Will AI help us discover completely new materials, things with properties we haven't even dreamed of? Could it help us uncover new laws of physics, fundamental rules that govern the universe? Will we see AI becoming co-authors on scientific papers, not just tools, but true intellectual partners?
These aren't science fiction questions anymore. This breakthrough suggests that the answers might be closer than we think. The fact that AI can now contribute to fundamental scientific discoveries, it opens up so many new possibilities. It's exciting and maybe a little bit intimidating at the same time.
So let's just recap the key point here. In a moment that wasn't marked by fireworks or grand pronouncements, an AI worked with a human scientist to solve a major physics mystery, one that had baffled experts for decades. And it wasn't just about raw computing power, it was about understanding, about finding hidden structures within the problem, about reasoning.
And this leads to a final thought for our listeners to ponder. If AI can help us solve these fundamental mysteries of the universe, what other challenges, the ones that seem impossible right now, might it help us overcome? What does this mean for the future of human knowledge, for how we make discoveries, for how we understand our place in the cosmos? This breakthrough, it really does invite us to think big, to consider the possibilities, both the exciting ones and maybe the ones that make us a little uncomfortable. Because the future, well, the future is unfolding right now.
It certainly is.
And it's happening faster than we think.